So this is the other problem type where we have a metal that we don't know the temperature of. So let's look at the picture that goes along with that. So we have the mass of the metal, which is 46.15 grams. And we also have the mass of the water, which is 107.35 grams. And we also have the initial temperature of the water is 21.8 degrees Celsius. So then what happens is that the metal goes into the water, and the new temperature is 26.2 degrees Celsius, but this happens to be the temperature of both the metal and the water. So what we're going to do is figure out now what the initial temperature of the iron is. So T in it of the metal, doesn't necessarily mean iron, but it could be any metal there. But we need to first of all look at the heat that was released into the water. We have a lot of data about the water here. We have the mass, we have its final temperature and its initial temperature as well. So they're both there. And we also have the heat capacity of the water as well. So let's go ahead and start with the water. So QW is going to equal MW CW delta TW. The mass of the water is 107.35 grams. The heat capacity 4.184 joules per gram per degree Celsius. And the temperature difference here is 4.4 degrees Celsius. Now we get that by taking 26.2 degrees Celsius and we subtract 21.8 degrees Celsius. So that leaves us with, well, once we adjust for significant figures, 2.0 times 10 to the 3 joules. And the heat released by the water, or sorry, the heat gained by the water is going to be equal to the heat released by the iron. So QW is going to equal QFE. So now we go over here and we start with the QFE is equal to, I'm saying it's iron, but it could be any metal, MFE, CFE, delta TFE. Now the change in temperature of the iron is going to be QFE divided by MFE times CFE. Now I substitute in those values. We got 2.0 times 10 to the power of 3 joules. The mass of iron here is 46.15 grams. And the heat capacity is given as 0.2247. And that's joules per gram per degree Celsius. Now this comes out to be 190 degrees once we adjust for significant figures, which is going to have to be 2. So then we can figure out what the initial temperature of the iron was. Now we've got to figure out what happened to the iron. You'll notice that the temperature of the water went up. So the temperature of the metal must have gone down. What that means is the initial temperature of the iron is going to have to equal 190 degrees Celsius, which was the change in temperature, plus 26.2 degrees Celsius, which is going to come out to be 216 degrees Celsius once we put in the significant figures. So the important point here is that since the temperature of the water went up, and we know it did because it started at 21.8 and it went to 26.2, that means the temperature of the iron must have come down. Its final temperature was 26.2, which means its initial temperature would have been 26.2 plus whatever difference we found, which brings us to 216.